Okay, second video of the series, let's get into normal and non-normal distributions. So towards the tail end of the first video, we had talked about the bell-shaped curve and we had talked about percentiles as a way to provide an understanding of where any one particular score fits relative to other scores in the data set. So a couple of characteristics when it comes to what a normal distribution is it has to have these four characteristics. So they include being bell-shaped, being asymptotic, being symmetrical, and being continuous. So bell-shaped means that this blue line here, this curve, has a bell-shaped pattern. Asymptotic means that the curve never actually touches the black baseline on the x-axis. Rather, it floats above the baseline. The third thing is what's called being that it's symmetrical. So if it's symmetrical, it means the mean, the median, the mode are all going to equal 0, and half the scores are going to fall above and half the scores are going to fall below. And so that symmetrical nature means that the area to the right of this center line has to be about the same as the area to the left of the center line. And then lastly, we're talking about continuous characteristic, which basically means that scores that fall along and we can assign a frequency to have to fall along the number line. So they are often interval or ratio level of measurement, but they don't always have to be interval and ratio level of measurement. So what happens, and I get this question a lot, when the normal distribution or one of these four characteristics is not met in a distribution? So this is what we call skewness. So skewness is a way in which we measure the symmetry or lack thereof of the normal distribution. And so the skewness value can either be positive, it could be negative, or it can be undefined. So graphically, I teach students that skewness could easily be seen when looking at the normal distribution. So clearly, the two red lines that you see here for this current slide has what's called negative skewness and positive skewness. The bottom line is in both of these situations, regardless if we're looking at negative skewness or positive skewness, is that we know for sure that these two graphs, this one for negative and this one for positive, do not look like this, which is a perfectly normal distribution. And that's because some of these characteristics are violated. The first thing that we know for sure is that the shape of this curve is no longer bell-shaped, right? It's skewed or it's thrown off a little bit. And so when we look at the distribution, how do we know then if it is positively skewed or if it's negatively skewed? There's a couple of ways that we can train you to be able to tell the difference. So if we look at a positively skewed distribution, notice that the tail of the distribution is towards the right, which you can remember as scores on a number line move from left to right, where left is smaller numbers and right is higher numbers. So if the tail goes right, that's moving in the positive direction, and that means that we have positive skewness. Similarly, if the tail is going left, up and down, sloping down to the left, that means we have negative skewness, okay? So you can look at the graph, and the first thing that you have to say to yourself is, this shape of the curve does not look normally distributed. It looks skewed, okay? How do I know if it's positively skewed or negatively skewed? I could look at the tails, where if the tail is sloping down and it's moving to the right direction, it's positively skewed, and if it's sloping down to the left, it means it's negatively skewed, okay? Other ways in which you can detect skewness without using a graphical representation would be through using what's called skewness and kurtosis statistics, which we talked about during the week 1 lecture videos. The other way in which we can identify a non-normal distribution is by using kurtosis. So kurtosis represents the height of the curve. So the curve is either going to be too peaked or it's going to be too flat. Okay, so in a perfectly normal curve, remember, it should be bell-shaped. So if it's too peaked, that means that it has positive kurtosis. And if it's too flat, as you see here, that means that it has negative kurtosis. What we typically call a positive kurtosis is called a leptokurtic distribution. So leptokurtosis refers to a positive kurtosis distribution or a peaked curve. A platykurtic distribution, on the other hand, represents a flat curve, as you see here, very much like a low arch of a foot. So kurtosis is a way in which we can look at the data and get a sense for whether or not the tails are very thin or if they are very heavy, okay? But really, kurtosis is all about looking at the height of the distribution and determining if scores are bunching around the mean, as they would be in a leptokurtic distribution, or if they are very spread out and we have a platykurtic distribution. So we can do it with kurtosis as well. Okay, in the next video, we're going to go ahead and talk a little bit about probability.